So how are you going to get to the point where you are confident that you can create the real silicon with 220 cores that
yeah, no,
work?
yeah, absolutely. I mean, we're really confident we can do that. What as soon as we've got that that whole of that messaging system working, then you can dial in basically as many as you like, and then we test it, we verify it, we start running some customer projects on it. But in parallel to that, we can start making silicon. So at that
Okay,
point,
so are you saying that once you got to the 8 core stage, if once all that's working and the messaging is working, you could then press the go button to
absolutely,
create? Is that
absolutely.
is that the plan then? Once you've got the 8 cores working and the messaging, you'll then say, okay, in parallel, we're now going to I don't know. Have you got designers who are then going to design a 220 core chip? I mean, how does that happen in practical
I
terms?
mean, it's more or less cut and paste.
Oh,
This is
okay,
not rocket science. Once
right,
we've got any number that's more than more than two,
yeah,
we've effectively got the system. So that allows us. So we picked 8 because it happens to fit on a cheap FPGA we've got some of
right,
kicking around, not because it's a meaningful milestone.
okay,
As I say, that same day we could also just cut and paste some more in and run it on more with the bigger FPGA. So the number of cores actually is not one of the nice things about the architecture is it's very scalable. So in the long run, people
yeah,
get excited about this, and we're not doing any of this for the moment. And apart
yeah,
from that, tape out costs are so high.
yeah,
But
yeah,
there's
yeah.
nothing stopping you doing 1,000 core, or 5,000 core, or 10,000. In fact, we designed the architecture to be able to go up to 64,000 cores.